Hello everyone. Our today's topic for the A-level chemistry is from the chapter organic nitrogen compound. We have discussed in the previous lecture about amines. Now today we are going to discuss formation of amines, how amines are formed. General formula, general representation of amine is just like this. This is aliphatic amines. Now amines are produced or formed by the nucleophilic substitution reaction. Now in nucleophilic substitution reaction, if we treat this bromoethane with excess of ammonia in the presence of alcohol, then nucleophilic substitution reaction will take place and we will get ethylamine and HBr. The purpose of the use of excess ammonia, concentrated ammonia, is to convert this HBr produced into ammonium bromide. Otherwise, this HBr might react with this ethylamine just like this. If this react with ethylamine, it can produce ammonium ion, ethyl ammonium ion, CH3, CH2, NH3 positive, and then bromide. Ethyl ammonium bromide will be formed. To prevent this formation, the excess of ammonia is used, which will capture HBr produced and convert it into ammonium bromide. Next, if this ammonia is not used in excess, then this ethyl amine produced that also has a lone pair on nitrogen atom, so it can also act as a nucleophile. If this will act as a nucleophile, definitely we will get the secondary amines. How? If in the next step, if ammonia is not in excess but ethyl bromide is there, then ethyl bromide will start reacting with this ethyl amine, CH3, CH2, NH2. This is primary amines. Now, this will act as a nucleophile, will attack on the positive charge carbon atom, producing what? This will be produced CH3, CH2, NH, and then CH2 and CH3. Means a secondary amines will be produced, and this is the diethylamine. Further, this diethylamine can also attack on another molecule of bromoethane and then can produce, substituting this hydrogen with again CH2 and CH3. This will produce triethylamine. A tertiary amine will also be produced, but still on nitrogen a lone pair is present. This tertiary amine can further be used as a nucleophile, can attack on the bromoethane, and now in the last step it can produce quaternary ammonium ion. this will be represented just like CH2 and then CH3. All these groups will be represented just like this. Now, this is quaternary mean 4. Quaternary ethyl ammonium bromide. Quaternary ethyl ammonium bromide, if the same amine is attacking bromoethane step by step, definitely as a result we will get secondary, tertiary and quaternary ammonium salts. So, if we want to prepare only the primary amines, we take this concentrated ammonia and alcohol in large excess, which eliminate all these possibilities, and we get only one product, ethylamine, as a result of nucleophilic substitution. Now, the second nucleophilic substitution reaction can be performed using potassium cyanide salt in the presence of alcohol. In this case, again, this cyanide ion will act as a nucleophile. This will attack on carbon atom and automatically substitution will take place and we will get, for example, this product CH3, CH2 and CN. As due to the CN, one carbon is increased, so this will be propane nitrile formed from bromoethane. Now, if here we want to prepare ethane nitrile, we have to take the starting substrate molecule containing one carbon atom, because the second carbon atom will come from the cyanide automatically. Now, this reaction is also used to increase the carbon atom chain. So, whenever we will use bromoethane, we will get propane nitrile. If we will use bromomethane, then we will get ethane nitrile. If we use bromopropane, we will get butane nitrile, and so on. In this manner, we can prepare all these. Now, these nitriles can be converted into amines by reducing them. One of the method is that vapor of these nitrile and hydrogen gas is passed through nickel as a catalyst, and nickel will turn this molecular hydrogen into atomic hydrogen, and as a result, what will happen? This will be added up into the molecule, producing this propyl amine. This propyl amine will be produced as a result of reduction of propane nitrile with hydrogen gas in the presence of a nickel. This reaction can be done, and similarly, this reaction can also be done by using lithium, aluminium, tetrahydroaluminate, which is a strong reducing agent in the presence of dry ether. There should be no moisture because this lithium tetrahydroaluminate hydroaluminate is a very reactive substance which will react with moisture very fastly, producing hydride ion. That's why we use dry ether condition, and this hydrogen will also be used for the reduction purposes. In this case, we can again get this propylamine. In this manner, we can convert these nitriles on reduction with any suitable strong reducing agent into the respective amines. How nitriles are prepared? Nitriles are prepared by the nucleophilic substitution reactions of halogenoalkanes. How many carbon atoms we want to take into our product? One carbon should be short in the starting substrate molecule. Automatically the number of carbon atom will be equalized. Now, the third method is by reducing amides. Amides can also be reduced. For example, if we take ethanamide, this is ethanamide structure. Now, this ethanamide can also be reduced using lithium tetrahydroaluminate in dry ether, and we will get automatically the product CH3, CH2, and then NH2. What will be the produced? What will be the product? Product will be then 2H2O. Water molecule will be produced along it. Now, in this case, the total number of carbon atom will remain the same, and this amide group, especially this carbonyl carbon, will be reduced and hydrogen will be added here and removing oxygen from this side. Automatically we will get the same number of carbon atom compounds here. This is ethylamine. Ethylamine we can produce in this method also. Now, if we want to prepare phenylamine, phenylamine, this is prepared from the nitrobenzene. This is the formula of nitrobenzene. Now, nitrobenzene can be reduced if we react tin with concentrated hydrochloric acid. This will react first, and this reaction will produce SnCl2, producing 2 hydrogen atom. This atomic hydrogen is utilized here. Reacting this along with this reducing hydrogen, this nitrobenzene can be converted quite easily into phenylamine, NH2, producing 2H2O. In this manner, water molecules are produced and this phenylamine is automatically transformed. And this phenylamine from the water is separated by steam distillation. by steam distillation. This is the method to separate this phenylamine. Why we use steam? We produce water vapors in a separate round bottom flask and then pass those water vapors through the mixture. Automatically the water concentration will remain the same and the heat energy of condensation that will be utilized to convert this phenylamine to vaporize, and those vapors will be condensed back to collect the phenylamine. If we heat directly, strongly, mixture of water with phenylamine, then it is a chances for the decomposition of phenylamine. That's why to avoid this situation, we use steam distillation for the separation of phenylamine. I have explained the method of preparation of amines. Either these are aliphatic or aromatic. Please comment, like, share and subscribe my YouTube channel for the upcoming videos. I thank you all.